Hello friends, today we are going to study chapter 2, that is electrostatic potential and capacitance. There are 7 focus area topics and 2 non-focus area topics. In that, the first one is electrostatic potential. Electrostatic potential, it is the work done in moving a unit positive charge from infinity to a point against the electric field. The potential due to a point charge, here there is a big derivation, but now I am not going into that, and just learn the formula that V is equal to 1 by 4 pi epsilon 0 into d by r. d by r. In the last chapter we had learned that E is equal to 1 by 4 pi epsilon 0 into q1 into q2 by r square. Here only one q is there, and in denominator only one r. So, yes, is electric potential a vector or a scalar quantity? It is a scalar quantity. And next comes a question. A regular hexagon of side 10 centimeter has a charge 5 mu 0 at each of its vertices. Calculate the potential at the center of the hexagon. So the question is to find the potential. In order to find potential, we have to learn a formula, that is V is equal to 1 by 4 pi epsilon 0 into q by r. Here each side constitute or measures 10 centimeter and the charge is 5 mu 0. 5 mu 0 can be written as 5 into 10 raised to minus 6, and 10 centimeter can be written as 10 into 10 raised to minus 2 meter. On substituting the value, and also we have to substitute 1 by 4 pi epsilon 0 is equal to k. The value of k is 9 into 10 raised to 9. When we substitute the value, we get 45 into 10 raised to 4 or 4.5 into 10 raised to 5. Then we have to multiply the current value into 6, because the question is hexagon. So we have to multiply with 6. Calculate the potential at the center of the hexagon. The question is to calculate the potential at the center of the hexagon. So in the question, each side and the charge is given, and to find the potential we have to know the formula. P is equal to 1 by 4 pi epsilon 0 into q by r, and on putting the value or substituting the value, we will get the answer is 45 into 10 raised to 4, and this value is multiplied to 6, and the final answer will be 27 into 10 raised to 5. The next comes equipotential surface. This is a very important topic. It is a surface having same potential at all the points. In all the points, the potential will be same. And there are 4 figures given here, but and in these 4 figures you have to learn this, and this, which are very important. And the properties of equipotential surface. The first one, the work done to move a charge from one point to another on the equipotential surface is 0. And second one, two equipotential surface will never intersect. Third one, the electric field lines pass normal to the equipotential surface. So I will repeat all those properties. The work done to move a charge from one point to another on an equipotential surface is 0. So the work done is equal to 0 in an equipotential surface. And the second point is the equipotential surface will never intersect. Third one, the electric field lines pass normal to the equipotential surface. Okay, the next question, what is an equipotential surface? The surface in which the surface in which all the points have same potential. Then the next question, give examples. For example, you can draw any one of these four pictures, any one from these four pictures, and write two properties of it. So you can write the work done in moving a charge from one point to another is 0, and the equipotential surfaces will never intersect with each other. Yeah, that's more than enough. Normally we have to learn 6 properties, but for now you just learn these 3 formulas, not formulas, properties. Okay, next question. Two charges 2 mu 0 and minus 2 mu 0 are placed in a point A and B 6 centimeter apart. The first question, identify the equipotential surface of the point, and B, what is the direction of the electric field at every point on the surface? Okay, just comment that answer on the comment box. And the relationship between electric field and voltage. Electric field is denoted by the letter E and voltage is denoted by the letter V. So it can be written as E is equal to V by D. So simply V is equal to ED. V is equal to ED. So the relationship between electric field and voltage can be represented by the formula E is equal to V by D, and which can be written as V is equal to ED. The most important topic in this chapter is capacitors. A question paper without capacitor is not possible. So the first topic is a device used to store electric charge is called capacitor. Okay, this is a capacitor. See the capacitors. All these devices are used to store the electric charge. Capacitor Q is equal to CV. C is a constant called capacitance. Okay, Q is equal to CV. Then it is the ability to store electric charge is called capacitance, and the SI unit is Faraday. Very important. So the expression for capacitance, Q is equal to CV. So C is equal to Q by V. And we know another formula, Q is equal to sigma A and V is equal to ED. If E can be written as sigma by E0. So we got the value of V. So substitute C is equal to Q. Q can be written as sigma A divided by V can be written as sigma by E0 into D. D in the numerator side. Okay. So C is equal to mu 0 into A divided by D. Just think of a situation when it is not in vacuum and it is placed in a medium. So the formula should be C is equal to E0 into ER into A by D. Okay. Okay. So a device used to store electric charge is called capacitor. Resistor is to resist the flow of electric current. Okay. SI unit of capacitance is Faraday. What happens if the dielectric medium is introduced between the plates of the capacitors? Definitely greases. Greases. How capacitance change if the distance between the plate of a parallel plate capacitor is halved? how capacitance change if the distance between the plate of parallel plate capacitor is halved. We know C is equal to epsilon 0 into A by D. So D can be written as D by 2. So 2 into epsilon 0 into A by D. That is, I'll tell you once more. C is directly inversely proportional to 1 by D, which means that when D decreases, C increases, and when C decreases, D increases. And another important formula we have to learn is C1 is equal to epsilon 0 into A divided by D, and D is halved, so D by 2. C1 is equal to 2 into epsilon 0 A by D, and epsilon 0 into A by D is equal to C1. So C is equal to it. The capacitance increase by 2 if the distance between them is halved. So what happens in this situation? It becomes doubled when the distance between them is decreased. Okay. And then in combination of capacitors there are two types. One is series and second one is parallel. And in series the formula is 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. And before few minutes I have said that Q is equal to CV. So what would be V here? V is V is equal to V is V. We have to calculate V. So Q is equal to CV and Q by C is equal to V. V can be written as V is equal to V1 plus V2 plus V3. So V1, that is Q1 by C1, then Q1 by C1, Q2 by C2, Q3 by C3. Then in all these situations Q is same, that is Q is equal to Q1 plus Q1 is equal to Q2 is equal to Q3. So the answer will be 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. In parallel combination, the answer should be C is equal to C1 plus C2 plus C3, and then Q is equal to Q1 plus Q2 plus Q3. V is equal to V1 plus V2 plus V3. In this situation, V is same. V is same, and here we have to calculate Q. Q is equal to CV. That is C1 V1 plus C2 V2 plus C3 V3. As I said that V is same, we can write C is equal to C1 plus C2 plus C3. Okay. So a question: 3 capacitor of capacitance 2 2, 3 and 4 are connected in parallel. Write the SI unit of capacitance. It is Faraday. Calculate the effective capacitance of the combination. Parallel. So just add the three values. 4 plus 3 plus 2. It is 9 pico-Faraday. You don't want to have changed it into Faraday. Just write as just given in the question. And the third question: calculate the charge of each capacitor of the if the combination is connected to a 100 volt supply. Determine the charge of each capacitance. Charge if the combination is connected to 100 volt supply. So we know Q is equal to CV. We know the value of C, then the value of V. So what is Q is equal to 900 C coulomb. Then yeah. The next is I forgot to say one thing. That is the most important thing while doing this question. It is said in the question. It is said that determine the charge of each capacitor. So you have to find Q1 is equal to C1, Q2 is equal to C2 into V2, Q3 is equal to C3 into V3. Energy stored in a capacitor, dW is equal to V into dQ. W is equal to integral of 0 to Q V into dQ. Then W is equal to 0 into Q. 0 to Q. V can be written as Q is equal to CV. So V can be written as Q by C. W is equal to, take that 1 by C outside because C is capacitance, which is a constant. So W is equal to 1 by C. Then on integrating, then here we will get so Q square by 2 minus 0 square by 2. U is equal to half Q square by C. You know what is the potential due to electric dipole? Potential electric dipole. So in the first chapter we learned that E is equal to 1 by 4 pi epsilon 0 into Q1 into Q2 by R square. And later we learned that 1 by 4 pi epsilon 0 into Q by R. And here we learned that V is equal to 1 by 4 pi epsilon 0 into P cos theta by R square. And then we have to know that P of a dipole in an external field. So U is equal to minus P into cos theta. W is equal to integral of tau into d theta. Tau can be written as Pe sin theta into d theta. So W is equal to Pe. Take Pe outside, and integral of sin theta is equal to minus cos theta by theta. But I don't know why they haven't written by cos theta by theta. Yeah. So we have completed almost 30 pages of electrostatic potential and capacitance. So the first topic was electrostatic potential, potential due to a point charge, equipotential surface, capacitance and capacitor, parallel plate capacitor, combination of capacitor, parallel and in series, the energy stored in capacitor, then potential due to electric dipole, potential of a dipole in an external electric field. So that I will just scroll through all these pages. This is the homework question. Comment on the comment box, okay? I hope that you understand all the topics, but I really wanted you to do the homework and write all the formulas in a sheet. Okay, today's homework, first homework I gave, and my second homework is to write all the formulas of this chapter in a sheet. Write all the formulas in a sheet, and after writing, comment that on the comment box that you have written, or else send that to me. Okay. So bye.